evaluate the double integral 1 to 2, negative 2 to 2 of x cubed minus y squared dy dx. Because we're integrating with respect to y, we're going to treat x as a constant. So we'll put a y next to it. And then the antiderivative of y squared is y cubed over 3. And we're evaluating it from negative 2 to 2. Okay, so for that, we'll get 2x cubed minus 8 over 3. That whole quantity minus, plug in negative 2 in for x, give negative 2x cubed. I'm sorry, we plug negative 2 in for y, not x. And then plus 8 over 3 dx. And then integrate this from 1 to 2. Simplify the inside. Here we have 4x cubed minus 16 over 3 dx. Integrate with respect to x now. We have x to the 4th minus 16 over 3x, evaluated from 1 to 2. And when we simplify this, we get 29 over 3 as our answer. We have another double integral. So integral from negative pi to pi, integral from 0 to 2, x plus sine of y plus 1, dx dy. Let's integrate with respect to x first. So we get x squared over 2 plus sine of y is a constant, so that's just x times sine of y plus x from 0 to 2. Plug in 2. So 2 squared over 2 is 2. And then you have another 2 here, it will be 4. And then 2 sine y. When you plug in 0 for x, you get 0. So we're not going to bother with that. Integrating it, we get 4y minus 2 cosine y from negative pi to pi. So it's 4 pi plus 2 minus negative 4 pi plus 2. And here the 2's are going to cancel, and we're left with 8 pi. Okay, now let's find the volume under the graph of the following function in the given region where x is between negative 1 and 1 and y is between negative pi and pi. Function is x squared times cosine of y plus 1. Okay, so here this will be a double integral, and it doesn't really matter whether you integrate with respect to x or y first. So let's just do with respect to y and then x. Y goes from negative pi to pi, and then x goes from negative 1 to 1. So let's integrate with respect to y. So the antiderivative of cosine of y is sine of y. And then go from negative pi to pi. And we're plugging pi in for y. So sine of pi is 0, and so is sine of negative pi. So that goes away. And so here you would have plug in pi for y. So you have pi minus negative pi, which is 2 pi. Evaluating it from negative 1 to 1. 2 pi is just a constant. So the easiest way to think about this is you have 2 pi from negative 1 to 1. So you're just finding the area of this rectangle, which is 4 pi. Let's change the order of integration and then evaluate the integral. So it's a double integral from negative 1 to pi over 2. Integral 0 to x plus 1. Sine of x dy dx. So whenever you want to change the order of integration, you want to first draw out the graph or the region. First, the limits here with respect to y. So this is y equals 0, y equals x plus 1. And then x is from negative 1 to pi over 2. So negative 1 is actually the x-intercept. And so the region that we're interested in is bounded between the line x plus 1 and the x-axis. So it's basically this whole thing. And you want to stop here at pi over 2. Now let's change the order of integration. That means we have to go dx and then dy. Okay, so x will be left to right. So the left function is y equals x plus 1, but you want to solve it in terms of x. So that means x is y minus 1. That goes down here. And then to the right is basically, you think of this as like a line, x equals pi over 2. So that's pi over 2. Y, we're looking at the y value. So the smallest y value is at 0. And then the highest is whatever is at this point. Notice that it's at x equals pi over 2. So we have, plug it in here, pi over 2 plus 1. So that's what this value is. Let's integrate with respect to x. We get negative cosine of x from y minus 1 to pi over 2. Okay, plug in pi over 2 in for x. So negative cosine of pi over 2 is 0. So you have 0 minus negative cosine y minus 1, which really is just positive cosine y minus 1. And then we have to integrate it from 0 to pi over 2 plus 1. So the antiderivative cosine is sine. And then we go from 0 to pi over 2 plus 1. Let's plug in pi over 2 plus 1 in here. We have sine of, the ones are going to cancel, so you're left with pi over 2 inside. And then subtract it. Plug in y equals 0, you get sine of negative 1. Sine of pi over 2 is 1. And then here the negative can come outside since it's an odd function. And we'll have 1 plus sine of 1. Okay, last question. We want to find the average value of the function over the given rectangle. The function is f of xy, x squared plus 2y cubed. The region is 1, 2 across 2, 3. So this is just a rectangle where the x values are from 1 to 2, y values 2 to 3. So really it's a square. It's a 1 by 1 square. Okay, now the form that we're interested in to find the average value is 1 over the area of the region, so area of R, and then double integral of this region, and then f of xy. So the area of the region is just 1 because it's a square with length 1. So I'm not even going to bother writing that out. The function is x squared plus 2y cubed. And here, because the limits are 1 to 2, 2 to 3, you can go in any order you want. So typically I just go with dy dx. Y is going from 2 to 3, and then x is going from 1 to 2. Let's integrate with respect to y. So that's x squared y plus y to the 4th over 2, going from 2 to 3. Plug in 3, you get 3x squared. And then 3 to the 4th is 81 over 2. Plug in 2. So you get 2x squared plus 8. And then integrate 1 to 2. But before we integrate, let's clean it up. So I dropped that square there. Okay, so we have integral 1 to 2, x squared. And then 81 over 2 is 40.5, minus 8 is 32.5. So it's x cubed over 3 plus 32.5x from 1 to 2. Notice that we'll be multiplying 32.5 by 2 and then subtracting it by 32.5 times 1. So that difference is going to be 32.5. X cubed over 3, let's see, plug in 2 is 8 over 3. And then plug in 1, you get 1 over 3. So basically that's 7 over 3 plus 32.5. And for that you get 209 over 6. And that's our final answer.